my beautiful learners, the Tshaka, your physical science educator from the Etsa Educational Project Center of Distinctions. So today I'm going to do the revision for the grade 11 learners on the topics of vectors. So please, my beautiful learners, let us study the vectors because they are going to be part of your November final examination. So let's start it. Let's start. Okay. Question 2. Let's check the marks that are allocated for question 2 is 13 marks. So my beautiful learners, it is possible for us to get that 13 marks. So now let's check question 2. Block A, which is at rest on a horizontal rough surface, is used as an anchor to hold block B with a mass of 56 kg in the air at a certain height above the ground. The two blocks are connected with rope R, which makes an angle of 35 degrees with the vertical. Block B is suspended from the ceiling with cable C. Refer to the diagram. And then block A experiences a frictional force of magnitude 200 Newton. The system is stationary. The system is stationary. Meaning when the system is stationary, it simply tells us that the forces that are moving upwards are balanced by the forces that are moving downwards. Meaning the sum of forces that are moving upward is equals to the sum of forces that are moving downwards. The sum of forces that are moving to the right is equals to the sum of forces that are moving to the left. And then for the fact that the system is stationary, it simply tells us that the acceleration of the system is 0. And when the acceleration of the system is 0, it tells us again that the F net of the system is 0. Okay, so now we come across the first question for 2 marks. The first question for 2 marks, it says define the term resultant vector. 2 marks. Define the term resultant what? Vector. What is a vector? My beautiful learners, when you define a vector or any other term, please do take the definition according to the way it appears on our examination guideline. If you are in a position of not having the examination guideline, please ask your teacher to print one for you, because of all the learners are expected to state the definition the way it appears on our examination guideline. Don't come up with your own definition. Please do make sure that you get the definition straight from the examination guideline. So now a resultant vector on our examination guideline is defined as a single vector that has the same effect as 2 or more vectors together. A single vector that has the same effect as 2 or more vectors together. And then option number 2 on this one, a resultant vector can be defined as the vector what? The vector sum of 2 or more vectors. Yes, the vector sum of 2 or more vectors, or a single vector that has the same effect as 2 or more vectors together. So obviously you will get 2 marks for stating a resultant vector either by this way or this way. And then we go to 2.2. 2.2 for 1 mark. What is the magnitude of the resultant acting on block B? My beautiful learners, the block B is not moving. The block B is not moving. That simply tells us that the F resultant on the block B, it must be 0. It must be 0, because remember that our system also is what? The system is stationary. When the system is stationary, if I can go back to Newton's second law equation, F net is equals to ma, we are required to determine the F net on B. Remember that B is not moving, or the system is stationary. When the system is stationary, it means that block A or block B, they are not moving. So when the system or block B is not moving, that simply tells us that the acceleration must be 0. And then when we have mass, and then we define our mass, we multiply our mass with our acceleration, obviously our F net is going to be what? It's going to be 0 as well. So 1 mark for writing 0 for 2.2. So now 2.3, my beautiful learners, draw a labeled free body diagram indicating all the forces acting on block B. The marks that are allocated on this question, they guide us by indicating to us the types of, or how many forces must be thrown. For the fact that the marks that are allocated on this question is 3, it simply tells us that the magnitude or the force diagram that must be on our free body diagram, we must be having 3, because the marks that are allocated there is what? Is 3 marks. If the marks were 4, that simply tells us that the forces that were supposed to be here, they were supposed to be 4. So but for now it's 3 marks, meaning I must draw only 3 forces. So now the first force that we come across here, I can say, is the frictional Fg, which is our gravitational force. Our Fg, which is our gravitational force. And then number 2, I have tension R. And then number 3, I'm having what? Tc. My beautiful learners, some other learners, they normally put the normal force. Normal force is we will only see the normal force when our object is on the surface. Like for instance, object A is on the surface, meaning when we draw the free body diagram for A, the normal force will be there. But for the fact that this one is not seated on the surface, we cannot have what? The normal force for this one. So please be careful. The normal force will only be there when our object is on the surface. It's either inclined or horizontal. The normal force will be there. But for this one, since it is not on the surface, we cannot have the normal force. Okay, or let me just draw the second free body diagram, but for now including I want to include the components on my free body diagram. So when I draw my free body diagram, that includes the components. Obviously I'm still going to have Fg, which is our gravitational force. But instead of drawing this TR, I'm going to resolve this TR into its components, the horizontal components and the vertical components. So this is what I'm going to have. What is this? This is TR, let me just say horizontal. TR horizontally, and then this one is my TR are vertical. And then I'm done with this one. For the fact that I put the components, there is no need for me to include the TR because of the components are already here. And then now let's come to this side. I want to resolve this TC into its components using tail to tail method. Obviously I'm going to have TV for C, and then I'm also going to have what TCH, which is the horizontal one. So meaning if you don't want to draw your Figure diagram in this fashion, you can draw your Figure diagram in this fashion. You will get 1 mark for indicating the FG, you will get 1 mark for indicating the components of TR, you'll also get 1 mark for indicating the components of what? Of TC, I'm sorry. And then you get your 2 marks. And then now let's proceed. Let's go to 2.4. 2.4, determine the horizontal components of force in rope R. Determine the horizontal components of force in rope R. As we can see here, block A, which is this one, it experiences a frictional force of magnitude 200 Newton. We know that frictional force is a force that opposes the motion of an object. And then in this situation, for the fact that on our statement we were told that A is at rest, it simply tells us that even the type of frictional force that we are having here, it must be a static frictional force. Meaning, if I'm having a static frictional force here, for the fact that it's static, the frictional force, which is the static frictional force, must be equals to the horizontal component of what? Of R. Meaning for 2.4, the horizontal component of force in rope R, obviously it must be 200 what? Newton. Why 200 Newton? Because the static frictional force of A is 200. And then for the fact that it is at rest, it simply tells us that the static frictional force is balanced by the horizontal component of what? Of R, which is also how much? 200 what? Newtons. Okay, so now let us go to 2.5. 2.5 for 4 marks. 2.5 for 4 marks. Calculate the vertical component of force in cable C. We are required to calculate TVC. Calculate the vertical component of force in cable C. Here is our cable C. Obviously, when we resolve this table C into its components, I'm going to have T vertical and then T what? Horizontal. But for now, we are required to calculate the vertical components, of force in cable C. So now, obviously, it must be TV. Okay, so let me show you how to do it. So I'm going to start first by saying that F net is equals to MA. How many forces are acting vertically here? How many forces are acting vertically? I have 1, 2, 3. And then I also have 2 forces that are facing upward, which is TVC and TRV. And then I'm only having 1 force that is facing downwards, which is our FG. So in this situation, the direction is important. The one that are moving upwards or that are facing upward, let us take them as what? As positive. And then the one that are facing downwards, let us take them as what? As negative. So meaning in this situation, I'm going to have TVC plus TRV minus FG is equals to MA. Okay, So now we are looking for TVC. But before I can come here, I want us to determine the TVR and an FG separately. Okay, FG, let me start first by determining the FG. FG, I know that is equals to M multiplied by G, or weight is equals to mg. And then obviously the mass that is given for our object B is 56. So I'm going to have 56 multiplied by, our gravitational acceleration is constant as 9,8 meters per second squared. So now when I press my calculator, 56 multiplied by 9,8, and then my answer there is 548,8 what newtons. So meaning in the position of FG, I'm going to put 548,8 newtons. Okay, so now let us determine the TRV or TVR. Now let's check, my beautiful learners. I do have this force. The force here, it must be 200 Newton. I hope we are together. And then this side is opposite to the angle. Is opposite to the angle. And then this side is the one that I'm looking for. This side is the adjacent side relative to the angle. So meaning I have three trigonometric ratio: sine, cos, and theta. In this situation, I am looking for the adjacent side, and then I am provided with the opposite side. So meaning the trigonometric ratio that I'm going to choose in this situation, it must be tan. So I'm going to say tan theta is equals to opposite over adjacent. What is my theta? The theta is given. So I'm going to say tan 35 is equals to the opposite side is that one of 200 over the adjacent side. The adjacent side now is T what? TVR or TRV. So now let us cross multiply. 1 multiplied by 200 is 200 is equals to tan 35 TVR. So now I'm going to divide both sides by tan 35, even this side tan 35. Tan 35 cancel tan 35, and then TVR is equivalent to 200 divided by tan 35, and then my answer there is 285,630 Newton. Okay, so from here I must go back to substitute. What is our TVC? Is the one that we're looking for. Plus, what is our TR? Our TVR is 286,85. I'm sorry, 85,630 minus, what is our FG? Our FG is 548,8 Newton, which is equal to the mass of our object is 56 multiplied by the acceleration of the system is 0. Why 0? Because the system is stationary. So from here, my beautiful learners, TVC, I'm going to say 285,630 minus 548,8, and then it gives us something like negative 263,17 is equals to 0. So now I must take this value to the other side, and then when I transpose this value, it must change what? A sign. So meaning our TVC is equals to positive 263,17 Newton. I hope we get it, guys. I hope we are all together. And then now I go to the last question, which is 2.6. I go to the last question, 2.6. Calculate the angle between the cable and the ceiling. So now we managed to get the vertical component of this triangle. The vertical component of this triangle, which is 263,17. And then remember that the horizontal component of this triangle, it must give us something like 200 Newton. It must give us 200 Newton. So now we are required to calculate the angle between the cable and the ceiling. So meaning I do have the opposite side, and the opposite side, which is 263,17, and then the adjacent side, obviously it must be 200 Newton. So obviously I am required to calculate the angle. I have the opposite side, I also have the adjacent side. So meaning the trigonometric ratio that is suitable for us to use here, it must be tan. So I'm going to say tan theta is equals to opposite over adjacent. Okay, tan theta is equals to the opposite side is this one, which is 263,17 all over. The adjacent side is that one of 200 Newton. So now I must put I must make theta subject of the formula. So if I make theta subject of the formula, I'm going to have something like this theta is equals to second function of 263,17 all over 200. And then now let us put everything on our calculator to get the answer. So second function of tan 263,17 divided by 200, and then our answer there is 52,77 degree. That is our final answer. And then one other thing, my beautiful learners, for us to get the same values before we get to the final answer, at least let us round off our answer within the question to 3 decimal places. And then when we get to our final answer, we are at liberty to round off our answer at least to 2 decimal places. So my beautiful learners, for now, let me allocate the marks for this question. Let me allocate the marks for this question. Okay, obviously for writing a single vector that has the same effect, you'll get 1. As 2 or more vectors added together, you'll get another mark. Or the vector sum of 2 or more vectors, you'll get your 2 marks for that. So please make sure that everything that is underlined is there when you write the definition, because of, remember what I said, the definitions are required the way they appear on our examination guideline. And then obviously for 2.2, for writing 0, you will get 1. And then 2.3, for drawing the free body diagram, obviously 3 marks. You will get 1 for TR, you will get 1 more, 1 for FG, you will get 1 for TC. When you draw it like this, like put in the components, you will get 1 mark for throwing the FG, and then for TRV and TRH you will get 1 because of they were resolved from TR. For throwing T, VC and THC, you will get another mark because those components were resolved from TC. For TC, okay. Obviously, when we get to 2.4 is only 1 mark. You will get 1 mark for that, and then 2.5 is 4 marks. Obviously, for writing F net is equals to MA, and then for indicating that the acceleration is 0, you will get a mark. And then for the whole thing, these two values, you will get a mark. Oh, I forgot to put a mark here. For F net is equals to MA, you will get a mark. And then obviously for the final answer, you will get a what? A mark. And then please do make sure that you put the SI unit, because of some other learners, they will just write 263,17 without a unit. Obviously, if you forget the units, you will get wrong. Okay. And then when we get to the last question, which is 2.6, for 2.6, we were asked to determine the angle. Obviously, for writing tan theta is equal to 263,17 divided by 200 for substitution, you get a mark. And then for the final answer, you get what? A mark. And then our total in this situation is 13 marks. So my beautiful learners, when you sit down for your final examination, please make sure that you relax and then you collect more marks. I hope we are together.